The topic is eutectic system and binary phase diagram of eutectic system. First, let us see what is eutectic system. Eutectic system is nothing but a binary system, which means two component or a system that is consisting of two substances, and those two substances might be a miscible liquid or immiscible liquids, but it do not react chemically with each other. So such a two component or binary system is said to be eutectic system. As an example, lead and silver is considered as a eutectic system. Lead and silver, which on combining forms an alloy, argentiferous alloy, is an example for eutectic system. And the phase diagram for the lead silver system is like this. Two factors are considered, taken in for the phase diagram. So the factor in the x-axis is composition, and factor in the y-axis is temperature. If we see the phase diagram, it consists of the following information, that is, it has got some curves, some regions, and a point called O. The curves are AO, BO, and the eutectic point is this point, that is O. So these two curves and a eutectic point. Some regions are available. The region above BOA, this zone is a region, and the region below the curve AO and region below the curve BO. So we see two curves, one eutectic point and three region, that is above BOA, below BO and below AO. So the following information are seen in the phase diagram of a two component system. So let us see what the curves, the areas, and the point represents, and the degrees of freedom that has to be specified for studying the system, lead silver system, in the curves or areas or the eutectic point. When the curve OA or AO is considered, it is said to be the cooling curve of silver, because, so consider this x-axis alone. So in the x-axis, the origin point represents 100% lead and 0% silver, and the end point that represents 100% silver and 0% lead, which means, so on moving from left to right, percentage of silver increases and percentage of lead decreases. Likewise, so this shows the increase in temperature. If silver is considered, 100% silver is considered at 961 degrees Celsius, the metal, it is in the form of fused state. Above 961, it is in the form of fused state, that is molten state. So likewise, when lead is considered, 100% lead, its melting temperature is 327, above which it will be in the fused state. So this zone refers to the liquid melts of lead and silver. Both silver and lead, it is in the form of its melt. So the curve AO represents the cooling. On decreasing the temperature, it represents a cooling curve of silver, which means on reducing the temperature, from the liquid melt, solid silver alone solidifies first. Further decrease in temperature, when the temperature falls below 327 degrees Celsius, the second metal which is present in the liquid, that is solid lead, it also starts to solidify. So therefore the curve BO is called cooling curve of lead. This curve is cooling curve of silver. This one is cooling curve of lead. So both the cooling curves meet at a point O, which is called eutectic point. So what is eutectic point? It is the minimum point where, or the point where the two curves meet and both the metals which was in molten state starts to solidify, starts to reappear in the two component system. So if we are to study the system in the curve OA, as we said, it is the cooling curve or freezing point curve of silver, and it represents this equilibrium, the equilibrium between solid AG and melt. Likewise, curve BO, that is a freezing point curve of lead, and that represents the equilibrium between solid PB and its melt. So if the system, this particular equilibrium has to be studied on the curve OA or BO, then the number of degrees of freedom, that is the factors that has to be fixed or varied, can be calculated from the reduced phase rule formula. F dash is equal to C minus P plus 1. The component, as we know, eutectic component, it is to 2, so the C value is 2. Number of phases, it is 2 phase, because here if we see both the equilibrium, here also solid phase, liquid phase, solid phase, liquid phase, therefore the number of phases are 2, and the P value takes 2. On calculation, F dash value, it becomes 0. So a small correction, that is number of components in eutectic is 2, and the phases for this equilibrium, uh, it is 2. Solid is one phase, melt is another phase. Likewise, between equilibrium between lead and melt also, it is solid liquid, so 2 phases. So on applying the formula, the value of P takes 2 plus 1. So substitution, the final value, does F dash is equal to 1, which means on the curve, to study the system on the curve AO or BO, the number of factors that has to be fixed is either this factor or this factor. One factor has to be fixed and another can be varied. So on fixing the composition or on fixing the temperature, the other factor can be varied and the system can be studied in the curves. Now point O, which represents the equilibrium between solid silver, solid lead and melt. All the three coexist. Solid lead, solid silver and or melt, all the three coexist. And to study the system at that point O, the number of factors that must be considered is obtained from the formula F dash is equal to C minus P plus 1, where the component is 2 component. Phases, it is all 3. 3 phases are coexisting and therefore it is 3 plus 1. The final answer F dash is equal to 0, which means such a equilibrium, existence of solid lead, solid silver and melt, can be applied at a particular temperature and at a particular composition. The temperature is 303 degrees Celsius and the composition is 2.6% Ag and 98.4% lead. Only at this particular composition and this temperature, this point O exists. Solid lead, solid silver and melt, all the three coexist. No factor can be varied. So the system is non-variant at point O. And now coming for the area above AOB. So considering this area above AOB. So here both lead and silver exist in the form of melt. So single phase is existing. So to study the system, that is molten silver and lead, the number of degrees are calculated as F dash is equal to C minus P plus 1, that is component is 2, phase is 1, because both are existing. Lead and silver, it is existing only in the melt form, so the phase is 1 plus 1, so F dash is equal to 2. So which means the system is bivariant. Both factors can be varied. Temperature, any composition can be fixed to understand the system. And this is another zone. AO, down to AO is another zone, down to BO is also another zone, where on calculating F dash, the F dash value is 1 because component is 2, the phases are 2. 2 phases are existing. In this zone, 2 phases. In this zone also 2 phases are existing. So the phase is 2 plus 1, final answer is 1, which means the number of factors that has to be specified is 1. So to study the system here or here, one factor should be fixed, the other can be varied.